Today what we're going to do is we're going to talk about another method of solving quadratics, and that's solving by what's called the square root method. What we're going to do first is we're going to review how to work with square roots. If you remember, this little symbol here is read the square root of 4, the square root of 36, the square root of 144. So what we're going to do is we're going to look at how do we find square roots. First of all, you can put these on your calculator. So if you'll go to your calculator, and you'll turn it on. You're going to go to New Document. Please don't save. And what you're going to do is you're going to go to the Add Calculator, which is number 1. If you look to put the square root symbol in on your calculator, you have the square root key and the control. So you're going to do Control square root, and the symbol shows up. And the first one we're going to do is the square root of 4. So you type in your number, which is 4. You hit enter, and it gives you 2. So the square root of 4 is 2. And now we're going to do the next one, which is the square root of 36. So we go to our calculator, we do the same step. You're going to do Control x squared. And our number is 36, so you type in your number, square root of 36, and it tells you that it is 6. So right here, the square root of 36 is 6. And really, our calculator only gives us the positive root. It could be positive 6, or it could be negative 6. So we're going to put plus or minus 6. So what I want to do is come back over here to the 2, and it could be plus or minus 2. Because remember, 2 times 2 is 4, and negative 2 times negative 2 is also 4. 6 times 6 is 36, and negative 6 times negative 6 is also 36. Okay, so we're going to do the same thing with the last one, the square root of 144. So again, we go to our calculator. We're going to go Control x squared, and then we type in the number 144. Enter. And it says that the square root of 144 is 12. So the square root of 144 is positive 12 or negative 12. And we put the plus or minus in front to mean positive 12 or negative 12. And again, that's because 12 times 12 is 144, and negative 12 times negative 12 is also 144. Now, if you'll look at these examples, the first 3 examples, they all come up to nice whole numbers. So these types of square roots are called perfect squares. And again, the reason they're called perfect squares is when we take the square root of these numbers, we get nice whole numbers. So what happens when we don't? Well, let's go on and let's look at the next example. If you'll look at number 4, it's the square root of 27. So what I'm going to do, I come to my calculator. I'm going to do the same steps, Control x squared, and I'm going to type in 27. When I do that, I get a decimal. So that means this is not a perfect square. We are not going to take decimals. We're going to simplify and leave it in what's called radical form. So what we do is we have to break it down. So again, when numbers are not perfect squares, you have to simplify. So how do we simplify? We can use our calculator. If you remember, to break this down into factors is something we did before, and it's where you go Menu, and then you choose Number, which is 2, and then you push 3, which is Factors. And up on your calculator, we'll see Factor, and you type in your number, 27. And when I do that, I get 3 to the 3rd. So basically, 27 breaks down to 3 to the 3rd. And if you remember, that's 3 times 3 times 3. So what we're going to do when we're doing squares and square roots is we look for a pair. And if you look at this, we look for a pair, and we have one pair of 3s. We have one pair. The pair gets to come outside of the radical sign. We have one pair, so I write the 3. This 3 that doesn't have a partner has to stay inside what I call the little house. So the 3 here has to stay inside. So again, you look for pairs. There's one pair. It gets to come out of the radical or out of the house. This 3 right here doesn't have a partner to play with or go to a party with, so he has to stay in the house by himself. So the square root of 27 reduces to 3 times the square root of 3. And that's how we simplify. So let's go on and let's try the next one. It's the square root of 72. The square root of 72, so we're going to do menu, 2 for number, 3 for factor, and we're going to type in the number 72 and then enter. It gives me 2 to the third times 3 squared. So right here, I know that I have 2 to the third times 3 squared. Those are the factors of 72. Again, remember that 2 to the third is 2 times 2 times 2, and 3 squared is 3 times 3. We are going to look for pairs. And again, why are we looking for pairs? Because taking the square root is the opposite of squaring. And when you square, you have a pair. So if you look, we have a pair of 2's. So that 2 gets to come out. And then we have another pair. We have a pair of 3's. So we have one pair, and that 3 gets to come out of the house. Now, what doesn't have a pair? This 2 does not have a pair to come out of the house with. So this 2 has to stay inside of the radical sign of the house. And now we simplify. 2 times 3 is 6. And therefore the 2 stays here, so we get 6 square root of 2. Let's go back over this. How did we get 6? Because we have a pair of 2's, so it gets to come out. We have a pair of 3's, so they get to come out of the house. 2 times 3 is 6. This 2 that does not have a partner stays in the house by itself. So again, our final answer for the square root of 72 is 6 times the square root of 2. Okay, and for those of you who can't remember the steps, let's write them over to the side before we forget. To find the factors, you do menu. So you hit menu, and then you hit 2, which is number. And then after that, you do 3, which is factor, and then you enter. Okay? So let's try the next one, the square root of 6. So we're here on calculate. I'm going to go menu, 2 for number, 3 for factor, and my number that I'm looking for is 6. Sorry, guys. Let me delete this, sorry. I did too much at once on this problem. So let's try it again. We're going to do menu, 2, 3, and factor 6, and we get 2 times 3. So right here, the square root of 6 is 2 times 3. We look for pairs. There aren't any pairs, so basically nothing comes out of the house. So this is going to stay the square root of 2 times 3, which is 6, and that's the answer. And again, the reason nothing comes out is we do not have a pair. All right, so let's try the next one. 2 times the square root of 18. So basically, we have 2 times, and we have the square root of 18. So we're going to break down 18. So we do the same thing. We go to our calculator, we do menu, 2, 3, and we type in the number 18. Enter. It gives us 2 times 3 squared. So right here, this 18 is 2 times 3 squared. And if you remember, that's 2 times 3 times 3. We look for pairs. We have a pair of 3's. So this 3 gets to come out and join the 2 that's already here. So this 2 is here. We bring this down. This 3 gets to come out. And this 2 right here that broke down in the 18 doesn't have a partner, so it has to stay inside the radical sign, or what some of us call the house. So the 3 gets to come out. The 2 that doesn't have a partner stays in. And when we simplify, 2 times 3 is 6, and we have the square root of 2. So our final answer is 6 times the square root of 2. And that's how we simplify square roots that are not perfect squares. So I'll give you a few seconds to get this caught up or written down. All right, so now what we're going to do is we're going to apply this to the square root method. And in order to work with the square root method, you have to get your equation in the form it has to be ax squared plus c equals 0 to start out with. And now what you want to do is you want to get the variable by itself. So just like we used to do when we were solving equations in the beginning, we're going to draw our line. We want to take this minus 25 and move it to the other side. And if you remember, the opposite of subtracting is adding. So we're going to do plus 25 on the left. And what you do to one side, you must do to the other. So we're going to add 25 to the right. We didn't do anything to the x squared, so he comes down. Negative 25 plus 25 cancels out. And we have equals 0 plus 25, which is 25. So we now have x squared equals 25. To solve this with the square root method, the opposite of squaring is taking the square root. So what we're going to do is we're going to take the square root of both sides. Again, because what you do to one side, you have to do to the other. The square root of x squared is always going to be x. Again, the square root of x squared is always going to be x. Equals, and I want to know the square root of 25. Well, first of all, I have to determine, is it a perfect square or not? So I'm going to go to my calculator. I'm going to turn it on. I'm going to go to calculate, and I'm going to do control x squared. The square root comes up, and I type in 25. Enter, and it gives me 5. Therefore, 25 is a perfect square. So the square root of 25 is positive 5 or negative 5. So the x value for the square root of 25 is 5 or negative 5. Now, what I want to do is write that as ordered pairs. My solution is 5, 0, because that's the x-intercept, or negative 5, 0. So that's how you write it as ordered pairs. And remember, the reason we write it as an ordered pair is the solution to a quadratic is the same as the x-intercept. Now, how would we write this as factors? The factors, if we were asked to write this as factors, because we don't know exactly how we're going to be asked, is you do your two sets of parentheses, and you have x and x. And remember, since this is a 5, when you bring it down, it changes its sign and it's minus. So the factor here would be x minus 5. And then here, since this is a negative 5, when we come here, it will be x plus 5. So again, what we have here is we have the values of x, which are plus or minus 5. We have the same solution written as ordered pairs, 5, 0 and negative 5, 0. And we have it written as factors, x minus 5 times x plus 5. Okay, so let me give you a few minutes to get caught up on that, or a few seconds. And now we're going to go on to another example. Okay, so if you'll look at this next one. Again, we're solving these. You want to get the variable by itself just like we did at the beginning of the year. So if you'll take this, you're going to divide your equation in half. And remember that we're trying to get x by itself. So the first thing we have to do is we have to move the 3. To move the 3, the opposite of multiplication is division. So we're going to divide by 3. And remember, if you divide the left by 3, you have to divide the left side of the right side of the equation by 3. 3 divided by 3 is 1, so we get 1x squared. And 15 divided by 3 is 5. And now I have x squared equals 5. Again, the opposite of squaring is taking the square root. So we're going to take the square root of x squared. And if you remember from the first semester, what you do to one side of the equation, you have to do the other. So we're also going to take the square root of 5. When I go to my calculator to check to see if 5 is a perfect square, I go on, I'm on calculate, I do control x squared, and I put in 5, enter. It gives me a decimal, so I know that 5 is not a perfect square. The square root of x squared is x. And again, the square root of x squared will always be x. Since 5 was not a perfect square, I need to do the factors. So again, we go menu, 2 for number, 3 for factor, and I type in 5. And when I hit enter, the only thing I get is 5, which means 5 does not break down. So we are going to leave this as the square root of 5, like we did on the 6 earlier in the examples. So the values of x are positive square root of 5 or negative square root of 5. And those are my values of x. I also want to write these as an ordered pair. So my ordered pairs will be positive square root of 5, comma 0, and negative square root of 5, comma 0. And remember, these are our ordered pairs. This is what it would look like if you were doing the graph, and those are your x-intercepts. And finally, the third way we want to write it are the factors. And if you remember, the factors are the values that will be multiplied. So we're going to have our x and our x. Since this is a positive square root of 5, here will be minus square root of 5. The sign changes. And since this is a negative square root of 5, when we come down here, it changes to positive, and it's the square root of 5. So again, the values of x are positive square root of 5 or negative square root of 5. Our ordered pairs are positive square root of 5, 0, negative square root of 5, 0. And our factors are x minus the square root of 5 and x plus the square root of 5. So let's go on now, and we're going to look at example number 3. Again, draw your line dividing your equation in half. Your whole goal is to get the x by itself. So we want to move this minus 180 to the other side. And if you remember, the opposite of subtracting is adding. So we're going to add 180 to both sides of our equal sign. When we do that, we end up with 5x squared equals 180. We need to move the 5. Remember, the opposite of multiplying is dividing. So we're going to divide both sides of our equation by 5. And when you divide, 5 divided by 5 is 1. So you're going to get x squared equals, and 180 divided by 5 is 36. Again, in order to get x squared to the x, to get it by itself, the opposite of squaring is taking the square root. So we're going to take the square root of x squared, and we're going to take the square root of 36, because what you do to one side of the equation, you have to do to the other. The square root of x squared is always x, and the square root of 36. Well, let's go to our calculator. So we're going to do control x squared, type in 36, enter, and it gives us 6. It's a nice whole number, which means 36 is a perfect square. So the square root of 36 is positive 6 or negative 6. So my values of x are positive 6 or negative 6. In order to write this as ordered pairs, it would be 6, 0 or negative 6, 0. And finally, to write it as our factors, and I'll put that down so we'll remember we're talking about our factors, are going to be x and x. When we bring this 6 down, it changes its sign, so this is minus 6. When I bring this 6 down, we do the opposite sign, so this is plus 6. So again, we have our values of x, our ordered pairs, and our factors. Okay, and we have one more, and this one's probably going to be the most difficult one. If you look at the way this was written, we have 3 times the quantity x minus 2 squared equals 36. Again, the first thing we want to do is we're going to draw our line through the equal sign to divide our equation in half. And now we're going to get x by itself. So what we do first is we want to move the 3. The opposite of multiplying by 3 is dividing by 3. So we're going to divide both sides by 3. The 3 divided by 3 leaves us with 1. So we're going to have the quantity x minus 2 squared equals, and 36 divided by 3 is 12. Now, if you look at this one, this whole quantity, everything in the parentheses is squared. So what we have to do is we're going to take the square root of all of this. So we're going to go the square root of x minus 2, squared equals, and if we take the square root of the left side of the equation, we have to take the square root of the right side of the equation. Well, what happens here is the square root and the square cancel out because they're opposites, and we are left with x minus 2. So everything goes away, the square root symbol and the square, and we're left with just x minus 2 equals, and we have the square root of 12. So we need to see what is the square root of 12. When we come to our calculator and we do control x squared and we type in 12, we get a decimal, which means that 12 is not a perfect square. So what we're going to have to do is we're going to come over here to the side and we're going to break this down. So again, you go to your calculator, you do menu, 2 for number, 3 for factor, and you type in 12. And it gives me 2 squared times 3. So what this means is 2 times 2 times 3. I'm sorry guys, the video went out for a while. It gives me 2 times 2 times 3. So what we do is we look for a pair. We have a pair of 2's. So the 2's get to come out of the house and play. And then the 3 doesn't have anyone to play with, so it stays behind. So we get the 3 here. So our answer is going to be plus or minus 2 square root of 3. So over here we write plus or minus 2 square root of 3. Now, I still need to get x by itself. So I'm going to add 2 over here. And remember, what you do to one side of the equal sign, you do to the other. And I end up with x equals 2 plus or minus 2 square root of 3. And that's going to be my solution for x. Okay? And for right now, that's how we're going to leave it. So this is how you solve quadratics by the square root method. Remember that if you're struggling, please watch the video again. Go through it as many times as you need. And then also you may come to tutoring.